47 earthquakes, same location, 3 weeks. Each one happening exactly 3 to 4 kilometers deeper than the last, like dominoes falling in slow motion toward the ocean floor. Scientists pulled up the data, and when they saw the pattern, their breath caught. Because they'd seen this before, right before Japan's 2011 megaquake that killed over 18,000 people. Right before Chile's devastating 2010 disaster, and now it's happening again. In the Caribbean, above the Puerto Rico Trench, the Atlantic Ocean's deepest and most dangerous fault line. And if you think this doesn't affect you, stay with me. Because what happens next could send tsunami waves racing toward every major city on the eastern seaboard. Let me tell you what's happening right now, at this very moment, 8 kilometers beneath the ocean surface. The Puerto Rico Trench isn't just deep, it's unstable. It's a 800-kilometer scar in the Earth's crust where the North American plate is being forced underneath the Caribbean plate at an angle that defies every standard geological model. And in March 2025, something changed. The trench started talking. That's what seismologists call it when earthquake patterns shift from random noise to organized sequences. And the Puerto Rico Trench just started screaming. Dr. Elizabeth Vanacore, lead seismologist at the USGS Caribbean Seismic Network, was monitoring routine data when she noticed something that made her double-check her instruments. A magnitude 4.2 earthquake struck directly above the trench. Nothing unusual there. Puerto Rico gets small quakes all the time. But then she looked at the location history. That was the 47th earthquake in that exact spot, in just 3 weeks. And every single tremor was occurring progressively deeper. 3 kilometers down, then 6.5 kilometers, then 10, then 13.5, a perfect descending staircase into the abyss. Now, before you click away thinking this is just another earthquake story, wait until you hear what this pattern actually means. Because Vanacore pulled up comparison data from other subduction zones around the world, and what she found will change how you think about Caribbean disaster risk forever. The signature was identical to pre-rupture sequences recorded before every major subduction zone disaster in recent history. Japan 2011, Chile 2010, Sumatra 2004. The pattern is so specific, so consistent, that seismologists have a name for it: stick-slip propagation. It's what happens when a fault that's been locked for decades, maybe centuries, starts to unlock, section by section, deeper and deeper, until the entire thing lets go in one catastrophic release. And here's where this gets personal. 3.2 million people live in Puerto Rico. About 2.4 million of them are within 10 kilometers of the coast. Most are sleeping in buildings constructed between 1950 and 1980, before modern seismic codes existed. They have no idea what's building beneath their feet, but scientists do, and what they're seeing is terrifying them. Let me explain what makes the Puerto Rico Trench different from every other fault line on Earth, because this is where the story gets strange. Most subduction zones follow predictable physics. The Pacific Ring of Fire, for instance, operates like clockwork. Denser oceanic plates slide beneath lighter continental plates at relatively consistent angles. Scientists can model these interactions with reasonable accuracy. They know when stress is building. They can estimate rupture timelines. But the Puerto Rico Trench plays by completely different rules. It's what geologists call an oblique subduction zone. The North American plate isn't diving cleanly beneath the Caribbean plate. Instead, it's grinding sideways while simultaneously being forced downward at a 20-degree angle. Imagine 2 massive puzzle pieces that don't fit being jammed together with the force of entire continents behind them. This creates multiple rupture pathways. A single earthquake here can trigger thrust faults, strike-slip faults, and transform boundaries simultaneously. Energy doesn't release in one direction. It releases in 3-dimensional cascades that spread like cracks in shattered glass. But wait, there's more. Recent seismic tomography reveals something even more disturbing. Beneath the main trench, at depths exceeding 150 kilometers, there's a massive slab tear. Part of the North American plate has literally ripped apart under the immense stress, creating a 3-dimensional maze of fractured crust. This fracture network channels stress in directions that standard models never anticipated. It's geological chaos. and it's accelerating. Stay with me here, because the next part is crucial. GPS arrays positioned across Puerto Rico detected something in late 2024 that had never been seen before. The island wasn't just moving northeast at its expected rate of 19 millimeters per year. It was accelerating. By January 2025, some stations were recording movement rates of 24 millimeters annually. That might sound minor. It's less than an inch. But in geological terms, it's the equivalent of slamming on the accelerator. Plates don't speed up unless something fundamental has changed in the stress balance below. Now let's rewind to December 2024, because this is where the timeline becomes genuinely frightening. While tourists celebrated Christmas on San Juan's beaches, seismic stations recorded 190 earthquakes in 72 hours. Most were magnitude 2.5 or smaller, too weak to feel, too subtle to make headlines. But the pattern they formed was anything but subtle. They created a nearly perfect arc stretching 45 kilometers along the trench's southern wall. And just like the March swarm, every tremor occurred roughly 3 to 4 kilometers deeper than the previous one. Vanacore's team ran stress analysis models on this sequence. The results were unambiguous. That swarm wasn't random seismic noise. It was a stick-slip propagation event, the exact signature that precedes major ruptures in other subduction zones. Before the 2011 Tohoku earthquake in Japan, similar deep swarms occurred along the Japan Trench. Scientists identified them only after analyzing pre-event data. The patterns were nearly identical to what's happening right now in Puerto Rico. And here's the thing that should terrify you. In Japan, those swarms preceded the magnitude 9.1 rupture by approximately 8 months. But there's context here that nobody's talking about publicly, and it changes everything. On August 14, 2024, something happened 1,400 kilometers southeast of Puerto Rico that set this entire sequence in motion. A magnitude 7.3 earthquake struck the Lesser Antilles subduction zone near the island of Martinique. Damage was moderate. A few collapsed buildings, some fractured roads. Within weeks, it disappeared from international news. Everyone moved on, except the Earth didn't move on. The energy released from that rupture traveled through the Caribbean plate at 8 kilometers per second. Those seismic waves arrived at the Puerto Rico Trench within minutes, hitting an already stressed fault network like a geological hammer. Advanced finite element modeling conducted by researchers at the University of Puerto Rico shows that the August event increased what's called Coulomb stress along the northern section of the trench by approximately 0.3 megapascals. That's enough to bring faults already near failure significantly closer to rupture. And here's the smoking gun. Within 3 weeks of the Martinique earthquake, Puerto Rico's seismic activity increased by 300 to 40%. Most were microtremors, magnitude 1.5 to 2.0, barely detectable without instruments. But they clustered along specific segments. They migrated systematically northward, and they occurred at depths that suggested something even more disturbing. Magma interaction with fracture zones. Yeah, you heard that right. Magma. Because most Caribbean disaster scenarios completely ignore something critical. The Puerto Rico Trench isn't just a seismic hazard, it's also a dormant volcanic arc. About 50 million years ago, the Caribbean experienced massive volcanism. That activity stopped around 30 million years ago, when the subduction geometry changed. The volcanoes went quiet, cities were built on their slopes, resorts appeared, golf courses, everything you'd expect in the tropics. But the magma chambers didn't vanish. They cooled, crystallized, became underground reservoirs of semi-solid rock sitting at temperatures around 800 degrees Celsius, just waiting. Recent magnetotelluric surveys, which detect underground electrical conductivity, found something deeply concerning beneath the central Puerto Rican mountains. At depths between 15 and 20 kilometers down, there are anomalous high conductivity zones. In volcanic terms, that's the signature of partial melt. Magma that's heated enough to start flowing again. A major earthquake along the trench could do more than shake buildings and trigger tsunamis. It could reactivate volcanic systems that have been dormant for millions of years. Sound far-fetched? In 2011, the Tohoku earthquake didn't just devastate Japan's coast, it also triggered volcanic unrest at multiple Japanese volcanoes previously considered stable. including Mount Fuji, increased seismicity, ground deformation, magma movement at depth. The Puerto Rico Trench's next major earthquake could pull the exact same trick, except this time, nobody's monitoring for it. Now let's talk about the tsunami scenario that keeps oceanographers awake at night, because this is where things go from bad to apocalyptic. The standard assumption goes like this. A magnitude 8.0 earthquake ruptures the trench. Seafloor displacement generates a tsunami. Wave heights reach 5 to 10 meters offshore. Coastal areas get 15 minutes of warning. Damage is severe but manageable. That's the optimistic version. That's the version that assumes everything goes according to the models. Here's what recent bathymetric mapping actually revealed. The northern wall of the Puerto Rico Trench is covered in massive submarine landslide scars. I'm talking about debris fields 50 kilometers long and 10 kilometers wide. Geological evidence suggests these failures occurred during past megaquakes, when violent shaking destabilized the steep underwater slopes. One particular scar, designated the Arecibo Amphitheater, shows evidence of a prehistoric landslide that moved approximately 400 cubic kilometers of material. For scale, that's twice the volume of Mount St. Helens' 1980 eruption. Except this happened underwater, instantaneously, displacing an incomprehensible amount of ocean. If a similar submarine landslide occurs during the next major earthquake, the tsunami wouldn't be a simple displacement wave. It would be what's called a splash tsunami, the kind generated when massive volumes of rock suddenly collapse into deep water. Modeling conducted by the National Oceanic and Atmospheric Administration suggests such an event could produce initial wave heights exceeding 30 meters in some coastal areas. Not 30 meters offshore where it dissipates, 30 meters at the coastline, hitting buildings, hitting people. And here's what makes this even worse. Those models assume a single landslide. There are at least a dozen major scarps along that northern wall. Let me paint you a picture of what March 2025's earthquake swarm actually looked like on the seismologist's screens, because this detail matters. The 47 earthquakes I mentioned earlier weren't evenly distributed across the trench. When researchers mapped their epicenters, they found something that made zero sense under standard tectonic models. The tremors formed two distinct lines, one following the main trench axis, exactly where you'd expect, but the other cut perpendicular through Puerto Rico's interior, tracing the path of the Cerro Godin Fault, a strike-slip system running east-west across the island's center. Two different fault systems, activating simultaneously. Dr. Krista von Hillebrandt Andrade, who manages the Caribbean Tsunami Warning Program, addressed this during a closed-door March conference. Her exact words, according to meeting notes, were chilling. "We're seeing fault interaction we didn't know was possible here. The trench is communicating with inland faults in real time." Translation? A megaquake along the trench could trigger secondary ruptures inland, magnifying destruction far beyond the coast. This isn't a tsunami problem anymore. This is an island-wide structural collapse scenario. Let's get specific about what that actually means for the people living there. Puerto Rico has 3.2 million residents. About 2.4 million live within 10 kilometers of the coast. The island's critical infrastructure, highways, hospitals, water systems, power plants, was largely built between 1950 and 1980, before modern seismic codes existed. The capital, San Juan, sits on a narrow coastal plain backed by steep hills. Most buildings are reinforced concrete, but the reinforcement standards used decades ago are now known to be catastrophically inadequate for magnitude 8.0 plus events. A recent engineering study identified approximately 8,500 buildings in the San Juan metropolitan area that would likely experience structural collapse, not damage, complete collapse, in a magnitude 8.0 earthquake. The island has 69 hospitals. Only 14 have been retrofitted to current seismic standards. The rest would likely lose operational capacity within minutes of a major quake. And water infrastructure? San Juan depends on the Caraizo Reservoir, fed by the Loíza River through a system of dams and aqueducts built in the 1950s. The main aqueduct crosses the Cerro Godin Fault in 3 locations. Engineering analysis suggests it would rupture during a magnitude 7.5 or greater event, cutting water supply to nearly 1 million people immediately. Then there's the power grid. Puerto Rico's electrical system, already fragile after Hurricane Maria's devastation, relies on aging transmission towers and substations concentrated along the northern coast. A major earthquake combined with tsunami inundation would likely destroy 60 to 70% of the island's generation and distribution capacity. No power means no water pumps, no hospitals, no refrigeration, no communications. And here's the nightmare scenario that emergency planners don't want to discuss publicly. In September 2017, when Hurricane Maria approached, Puerto Rico executed the largest hurricane evacuation in Caribbean history. Roads jammed for days, airports overflowed, ferries ran continuous schedules. It took 4 days to evacuate vulnerable coastal populations. 4 days of warning because weather forecasting gave authorities nearly a week of lead time to prepare. For a Puerto Rico trench megaquake, the island would have essentially zero warning. Shake alert, the earthquake early warning system used in California, can provide 10 to 30 seconds of warning before strong shaking arrives. Puerto Rico's seismic network, while functional, lacks the density and real-time processing capability to offer meaningful public alerts. Even if warnings worked perfectly, what's anyone supposed to do with 30 seconds? Evacuate a hospital? Shut down a chemical plant? Get children out of schools? The brutal reality is that 2.4 million coastal residents would face the earthquake with essentially no preparation. Those who survived the initial shaking would then have approximately 15 minutes before the tsunami arrives. 15 minutes to move inland through debris-choked streets, past collapsed buildings, with no power, no communications, and no clear evacuation routes. Now let me tell you something that's not being discussed in public forums. Puerto Rico is bankrupt. The island declared a form of municipal bankruptcy in 2017 with roughly $74 billion in debt and $49 billion in pension obligations. Recovery from Hurricane Maria cost an estimated $90 billion. The island's economy has been shrinking for nearly 2 decades. Population is declining as residents flee to the mainland. Tax revenue is dropping. And now imagine layering a magnitude 8.0 plus earthquake and tsunami on top of this existing crisis. The USG's haywired scenario modeled a similar event for the San Francisco Bay Area and estimated economic losses at $200 billion, but the Bay Area has significantly better infrastructure, emergency response capabilities, and financial resources than Puerto Rico. A conservative estimate for Puerto Rico puts economic losses at over $150 billion. That's 150% of the island's entire annual GDP. Recovery wouldn't take years. It would take decades, assuming federal aid flows at levels similar to post-Maria assistance, which arrives slowly and remains incomplete even today. Right now, at this exact moment, stress is accumulating along the Puerto Rico Trench at approximately 19 millimeters per year. That's slow, imperceptible, until it isn't. The last confirmed megaquake on this fault system occurred on May 2, 1787. Magnitude estimated at 8.1. The tsunami that followed killed hundreds and destroyed coastal settlements across the northeastern Caribbean. Contemporary accounts describe the ocean retreating so far that ships were left stranded on exposed seabed before the wave returned. Geological evidence suggests the average recurrence interval for these events is between 300 and 800 years, which means, statistically, the trench could rupture tomorrow, or it could remain quiet for another 5 centuries. Nobody knows. Except the recent acceleration changes that calculation fundamentally. When GPS data shows faster than expected plate motion, when seismic swarms cluster in patterns that mirror pre-rupture sequences elsewhere, when stress transfer from distant earthquakes pushes already loaded faults closer to failure, the probabilities shift dramatically. A 2025 probabilistic seismic hazard assessment conducted by the Puerto Rico Seismic Network calculated a 12% probability of a magnitude 7.5 or greater earthquake in the next 30 years. That's roughly the same probability California assigns to the San Andreas Fault producing a major event. Except Puerto Rico has a fraction of California's preparedness infrastructure. No early warning system, minimal building retrofits, limited emergency supplies, and a population that's largely unaware of the risk. In a windowless lab in Mayagüez, Vanacor's team is attempting something unprecedented. They're trying to map the Puerto Rico Trench's internal structure in real time using a technique called ambient noise tomography. Instead of waiting for earthquakes to generate seismic waves they can analyze, they're using the constant background vibration of ocean waves, storms, and human activity to essentially echolocate the fault's geometry. The preliminary results are revealing a level of complexity that's rewriting textbooks. They've identified at least 7 distinct fault segments that could rupture independently or together. The boundaries between these segments appear to be zones of abnormally high fluid pressure, possibly pressurized seawater that's been dragged down into the subduction zone over millennia. Why does this matter? Fluid pressure reduces friction. When friction drops, faults slip more easily. Those high-pressure zones could act as triggers, allowing rupture to cascade from one segment to another in what seismologists call fault unzipping. If the entire trench ruptures in a single event, you're looking at a potential magnitude 8.7 or greater. For scale, the 2004 Indian Ocean earthquake that generated the Boxing Day tsunami was magnitude 9.1. It killed over 230,000 people across a dozen countries. The Puerto Rico Trench, if it fully unzips, could approach that magnitude. And unlike the Indian Ocean, the Atlantic is surrounded by some of the most densely populated coastlines on Earth. New York, Boston, Miami, all would receive tsunami waves within hours. Here's what nobody wants to admit publicly. The Puerto Rico Trench has been remarkably quiet for over 2 centuries. Sure, there have been moderate earthquakes, like the 1918 magnitude 7.3 event, but nothing approaching the prehistoric megaquakes carved into the geological record. That silence isn't comforting. Seismologists call this a seismic gap, a section of active fault that hasn't ruptured in longer than statistical averages predict. These gaps don't indicate safety. They indicate accumulated stress. The longer a fault remains locked, the larger the eventual earthquake. Japan's Tohoku earthquake occurred along a segment of the Japan Trench that had been relatively quiet for centuries. When it finally ruptured in 2011, it produced a magnitude 9.1, far larger than most models had predicted for that region. The Puerto Rico Trench could be following the exact same script: building stress, locked solid, waiting for the trigger that sends it over the edge. So here's where we are. March 2025, 47 earthquakes in 3 weeks, each one deeper than the last. GPS showing accelerated plate motion, stress transfer from distant quakes, fault interaction patterns that shouldn't be possible, and a seismic gap that's been quiet for over 200 years. Scientists are watching, monitoring, analyzing every tremor, but they can't tell you when. They can only tell you it's coming. The question isn't if the Puerto Rico Trench will rupture. The question is whether those 47 earthquakes were the opening notes of a catastrophic symphony, or just another false alarm in a geological process that plays out over timescales humans can barely comprehend. Either way, the Atlantic's deepest fault is moving, building towards something the Caribbean hasn't experienced in living memory. And when it happens, millions of people will have less than a minute to react.